Right. Hello and welcome. So my name is John Bowerl. I'm
Oh,
with,
we've still not started it, by the way,
Yeah, you
John.
know that you need to. I can start it, so I'll
but
start
you're
it.
recording. Oh, you're gonna
Yeah,
take
I
this down?
started the recording now, and I'm going to do the start webinar now. But you did it very nicely. But there's no
It
one
was
here, so
Hello,
you know.
everyone here.
No. Listen. Look, you see participants. You see the patterns of
I
participants.
can't anymore because I had to schlep that off to the side because it's in.
So okay, so I'm not. I will WhatsApp you if there's someone
Okay, yeah,
joining.
that's a good idea.
I will WhatsApp you if someone joining. For now, we are alone, and I'm starting the webinar now.
Okay. Right. Hello, my name is John Bowerl. I'm with Sky, and today we're talking about modernizing cloud security and resiliency posture, right? The word of the year, and particularly when we're referring to brownfield environments, right? So if you've done your cloud migration or you've adopted your tooling for greenfields, one thing that a lot of people forget to think about is their brownfield, their existing infrastructure, their existing environments. Okay, so we're here today with two vendors and two partners, so to speak. We're actually here on behalf of Newware, the distribution partner for Europe for both Snyk and Gremlin. And we have Paul Harland on as well and Andre Newman from Gremlin. So Paul, can you introduce yourself?
I can. Hello, I'm Paul Harland, a solutions engineer here at Snyk, helping our partners and our cloud vendors actually understand and build Snyk into their propositions. Today, I'm going to be taking you through the platform and hopefully giving you some highlight into how that works. Thank
Excellent. Thank you, Andre.
And hey everyone, I'm Andre Newman. I'm a senior reliability specialist here at Gremlin. If you haven't heard of us, we're an enterprise reliability platform helping teams like yours build more resilient, more reliable systems. I write a lot of our tutorials and help a lot of our customers get along with getting started. So happy to talk to you about reliability.
Excellent. Thank you. And what we're going to do is we're going to take about 15 minutes each. I'm mostly going to speak about, about Sky and how we deliver these solutions, and also in particular about what's new at HashiCorp going up this year, right? So first of all, we're masters of digital transformation. So we're multi-cloud specialists, application infrastructure, and PaaS specialists. Personally, my passion right now is AI transformation, and I'm heavily involved with the Gen AI community. Data infrastructure, whether you're cloud or on-premise, again, platform engineering, Kubernetes, containerization, and more, and digital workspace. So we talk about end user compute as well. So a little bit about us again, and we're spread geographically around the world now. I'm based in London. Despite my accent, I'm actually based in London. We have 1,000+ customers, 800 top-tier certifications, 2,000 deployments plus, and our traditional core platform partners are on the right. You can see there. Typically, one unique offering that we have is the very low-level, highly technical consultation, right? So if anybody needs any custom plugin development or provider development, or even of certain solutions of these providers, that's one thing that we're uniquely really good at. Okay, so partnership again. Obviously, the big three of the cloud partners, we have AWS, Google, and Microsoft. HashiCorp, probably number two, and my background is actually HashiCorp, which is why I'm speaking about HashiCorp today. Broadcom and VMware as well. We've got vast experience with the entire VMware stack around the world. And along the bottom, not exclusively, right? This is a subset of our partners. We have Snyk and Gremlin here as well. Actually, we're not a Gremlin partner directly yet. We are sharing the Newware umbrella through distribution. And we are very interested in what they have to offer, which is why we've invited them today to speak. Right? So anything you see here and more, a full list of our partners is on our website. Okay. And a global select customers, again, a lot of companies you might recognize here. Anybody that wants a certain referral or reference or to speak to any one of our customers, please let us know. Technology partners, again, this is a subset, but obviously the big ones are the ones that I featured. And anybody that has any questions about them, again, please let me know. So one of the key things I'm talking about today, again, what's new at HashiCorp for this year. We are 1 month away currently from Hashi Days in Europe, Hashi Days London in particular for me. And there's a couple of announcements coming out, right? A couple of announcements that have already been in the works, like HCP Vault Radar, which maybe some of you have heard of, maybe not. We have a limited availability on that currently. I believe it's out of beta now, but still in limited availability. And I'll actually show you a little tour of it at the end of my kind of my overview. And this rebranding of HashiCorp Cloud Platform to essentially the infrastructure cloud. And what does that mean, right? So again, because the focus here is brownfield and discovery of existing problems and no stone unturned, so to speak, finding out what's wrong with your brownfield environment. This is something that's been missing traditionally on the HashiCorp side, right? Those who have used HashiCorp Vault for secrets management, a lot of people will install that, wash their hands of it, say, great, we're managing secrets now. We've taken care of this problem. That does nothing to evaluate secrets you're already leaking, right? So again, part of the feature set that has been missing from Vault, and part of the reason sometimes a Vault customer will come back 6 months later and say we've been compromised somehow, is that they haven't done a good review of their secrets currently, right? So what's out there? Do we have any hard-coded secrets? Is there anything exposed in GitHub? And this happens to everybody. Early days of most companies I've been at that were cloud focused, a new hire or someone will come and accidentally commit a credential to the cloud, which is one more reason we have Snyk here. Snyk, we'll talk about this in a little bit as well, preventing this from actually entering the code base. Vault now, with the Vault Radar, will actually go out there, scan your repos, scan your environments, and make sure that it will actually intelligently search for potential leak secrets that you should worry about. There's also false positives, obviously. There's a fine line between false positives and the opposite, right? Missing something that's actually a legitimate concern. And that should say secrets, Seacrest management outside of developers process, right? So actually it will, again, give you the little tour here in a little bit. And anybody that is curious to evaluate that, I'm sure if you talk to HashiCorp or ask us, we can arrange the limited availability trial. Or it's not really a trial, actually, it's an evaluation. So maybe you've seen there's a couple of YouTube videos that they released previewing what this looks like. This was kind of an outside project that was brought into HashiCorp to help this problem. Automated scan of cloud and on-premise environments, and these are kind of evolving as we speak. So new features are being added month by month. For the full release and the full latest state of affairs, again, tune into Hashi Days in June, the beginning of June, where we actually will probably see an announcement go down about this, right? So we'll take inventory, including severity, the source, type of secret that it suspects an issue is, and then a blast radius. Also remediation and recommendations, right? So it's actually fairly straightforward. It's fairly quick to do. And I will show you actually when I plugged in my own personal GitHub credentials just to see what it came up with. And I was actually kind of blown away what was in not just my own repos, but repos that I had forked. Excuse me. So what the interface looks like, and again, currently it's only available in HCP Cloud, again, on a limited basis. Even the screenshot here that you see, I believe is a little bit obsolete. The UI is kind of evolving week by week. So I'll show you what it looks like currently. So the data sources that are being added on the fly, again, being built out to make a robust solution include the SaaS options, things from GitHub, Cloud and GitHub Enterprise, again, private GitHubs as well. Any version control integration that you essentially could use as a Terraform Cloud source is, I believe, to be targeted by HCP Vault, right? So the CLI interface is available again. I've not used that yet. I've not seen access to that yet. There is everything. Everything is API based in most of HashiCorp's products, so I wouldn't be surprised to see this built in with part of your automation. Again, this is not real-time scanning, so this is not going to prevent you from doing a pull request, much the way Snyk will do. This is just about things that should be managed by Vault as you adopt Vault. Or if you've been a Vault user for a couple of years, you can still use this as well. Right, so discovery, correlation, remediation. This is here to tell you what is potentially leaked, how to fix it, and obviously offer you a smooth transition to transferring those secrets from a vulnerable space to being managed by Vault. Okay. Now, obviously, the goal of this, increase agility, decrease risk really is the biggest one. Reduced cost. In this case, if you're already using Vault, great. It's just an additional feature that gets flipped on in HCP. And that can save you a lot of trouble down the line, right, due to leaked secrets. Again, this was always a problem that someone installs a secret management solution. They think, great, I'm sorted. They call it done and dusted, and then pretty soon it turns out that they've had other secrets compromised. Okay. One more thing to top off again, HashiCorp Boundary is a product I've been a fan of since its announcement. This is finally catching on in the industry, right? If you're familiar with the zero trust solution stack that HashiCorp offered, this was the final piece of the puzzle, right? This is, I should say, the latest piece of the puzzle. So user access in a way that is PAM compliant, that is point-to-point policy instead of point-to-network with a VPN solution or a Bastion host. This is something that has evolved quite a bit, come a long way, and now finally is, I would call, polished in the HCP platform. So I'll show you a little bit about how you can use this to people who are working from home, working remotely, that access over a VPN can have a much more granular control over what they can access, what they're recording about users, and what essentially audit trail that is providing along the way. Okay, so again, how this works, Boundary, if you're not familiar, has the concept of controllers, right? The control plane essentially is a central place to configure your network and your access points dynamically, right? So instead of just IP addresses, you're now going to have things like tags or domain name wildcard matches or port scans, right? A certain port that you expect to be hosting a dynamic service, and then expose that via policy, via single sign-on authentication and authorization to have a user directly connect to that system and that port, or that cluster of systems and that port, right? Wherever it may be, because IP addresses change all the time and network endpoints may change, gateways may change, and there's no way to update that consistently in a traditional network, right? So this is a big deal. I'm a big fan. Again, this is another product that you may not just want to use in your business. You may want to use in your private life, in your academia, in your home labs. Anybody can benefit from this. Really, it is a really handy product. Okay, so really quick, I'm going to cut over to the cloud platform and show briefly, and then I'm going to hand over to Paul. Right. Okay, cloud.hashicorp.com. And actually, you know what? I have another window open here that's already got this session open. Let me see if I can center this in the right spot. Apologies. I'll fumble this in the middle. Here we go. And this is an organization we have again for partners at HashiCorp. So if you are logging into your own cloud platform, this may look a little different, but you can see if you've been an HCP user in the past, the number of options here used to be about half, right? So we see a few things happening recently within this HCP, this cloud platform, or this infrastructure cloud as it's being rebranded. We see finally Terraform Cloud being regionalized, right? So if you've been a Terraform enterprise user or a Terraform cloud user, but you can't use a SaaS hosted in the US because you have GDPR or data sovereignty concerns, this is finally available. You get your own instance of Terraform Cloud, so to speak, in HCP, which is a big deal. That's been a long time coming, right? So this will make it real simple for people to adopt, and I'm not sure what the pricing looks like yet. I think it's about to be announced, but look forward to that coming. It's going to simplify anybody's use of Terraform Enterprise by making the management so much simpler. Okay. So again, we have Vault Dedicated. That's the traditional way to get a Vault cluster. And now we have this Vault Radar, right? You may or may not have this again because it's limited availability. I'll cut over to my tab here, and you can see what it looks like. Once again, all I did was give it my own GitHub credentials and walk away for a couple of hours to let it scan. And this is what I came back to. Again, repos that I've not even created in some cases, like the ironically OpenBow apparently has a high severity credential, right? Who thought? That's ironic. If I delve into this, and my fork may not be currently up to date, but I can see exactly what's going on. I can see maybe there's a false positive. In this case, there's a testing JWT, right? It's clearly in a test file. Okay, I can skip that because it's obviously part of an insecure, or part of a secure kind of a faux environment, a testing environment. And this is the kind of thing, ironically, that Gremlin can talk about probably later, right? Going in and messing up the credentials or setting yourself up for failure to see what happens when things go wrong. But I have, again, a time that it was scanned. I have the author that committed it, which is really nice, right? I don't need to go to the git blame. I can see exactly where this credential came from, which is really kind of neat. That information is helpful. And in my own case, I actually got so many resources here. One of these projects that I wrote a long time ago, probably 15 years ago, and then eventually committed to the to a GitHub repo. I found that it had picked up a false positive, right? It had a OpenGL macro defined something about a pass, and it was a shader pass. Radar will pick this up and say, actually, this looks like a password. Should I make it a false positive, right? All you have to do is flag it as a false positive, and it will disappear from your report. Okay, very handy to have. And again, this is not just a grep of your repos. This is using a bit of ML, a bit of intelligence to figure out what it should be worrying about, what it should be letting by, right? So again, super handy. I've got a full report. I can give it a Git credential, GitHub credential, or a list of repos that I wanted to check. I just turned it loose on everything, right? And I say, okay, what in my entire GitHub account do I have to worry about? And it surprised me, actually came back with quite a bit. Okay, so again, enough about this. I'm going to jump over to Boundary really quick. Again, if you haven't used Boundary, there are a few new features that people have been asking about for a long time, and I think is really worth checking out. Again, a lot of people that, first of all, were worrying about session recordings. Session recordings traditionally required an S3 bucket in AWS, right? Well, look at this. We finally have an alternative storage, right? So if I have a private instance of Boundary controller, again, I have an air-gapped network, or I have a private network that is sensitive, or it cannot be connected to a SaaS such as Boundary on HCP. I can finally have a min.io, so I can have a local S3 instance. I still can't have local file system for my session recordings, as far as I know, but I do have the option to set up my own min.io instance or S3 instance and use that locally. So this is something that's been blocking a lot of people from Boundary. I would expect that Boundary will explode in interest quite a bit since this happened. Anybody that has any questions about either deploying Boundary, using Boundary, again, TerraSky is one of the premier partners for doing that. We were one of the first partners to get the HashiCorp security competency, specifically with an emphasis on Boundary. Okay, so again, the architecture of this, I have multi-tenancy, right? I have orgs and I have projects within orgs. I then am able to establish targets, right? Targets are connected to via Boundary Worker, which is essentially to me is a gateway, right? I run the gateway at the edge. It can be a VM, it can be physical, it can be technically it could be probably a serverless deployment or something in a container on the edge of the cloud. Or again, I've written a blog probably a year or two ago now about you can even run it on your home Wi-Fi router, right? So replace your VPN on your router with a Boundary Worker. It works really great. You control what services you're exposing here, and then people can't log in and see all of the environments, everything on your network, right? All they get is this single end-to-end connection. And also on the client side, there's a new feature which I believe will simplify connections with a local DNS. I haven't seen that yet, but there's some interesting features coming around the client that I look forward to. Okay. So again, if you are, sorry, I'm stuck in the Boundary client. I want to go back to HCP. If you're not familiar with this, or if you're exploring this, any aspect of HCP or HashiCorp Cloud Platform or Infrastructure Cloud, feel free to reach out to us through the new Aware connection. Okay, so thank you. And Paul, I'm going to turn over to you if you're ready.
Yes, I am indeed. If I could just share my screen. And thanks for that handover, John. Yeah, and I'm here today to talk about Snyk. If you've not come across Snyk before, what we are a developer-first application security platform. So we're here to empower you as organizations to continue to develop fast while staying secure. So we're always thinking about that shift left, that DevSecOps motion. How can we, in the modern role as a developer, help them understand, assist developers in actually finding and fixing these vulnerabilities? Now, when you want to think about security, actually developer security is one of the pillars, but clearly you need other things as well. Now, we're here to kind of introduce that extra pillar of security for developer security, as in the past, people just assume that if my endpoint, identity and access management, and IT infrastructure security was sorted, then my whole environment is secure. But if you do put a vulnerable application, whether that vulnerability comes from the code you're writing, the open source or the container, onto that infrastructure, you can still be liable for a hack there. So you need to be thinking about the applications you're developing and ensuring they're secure before they're put on your cloud infrastructure. So what's within the Snyk platform? Well, we've got a number of capabilities. First of all, we've got Snyk code. That's static analysis, looking at the code that you're writing and helping you find and fix the vulnerabilities. Snyk open source, looking at the open source you're using, looking for versions that are vulnerable and helping you updating those. We can either do that manually or automatically, again, helping you with that scale of your security program. We do similar things for Snyk container, look at the open source components or the composition of that container and help you update it. And as well, infrastructure as code. So your Terraform, your Helm charts, your ARM templates, your CloudFormation scripts, anything in that realm we're helping keep secure. On top of that, we've got what's called Snyk at Risk. And today we've actually just launched Snyk at Risk Pro. Essentially, it is an opinionated ASPM framework or platform geared towards, again, the developers understanding how they can fix the right things with the minimal effort, prioritization, and understanding what they should be fixing. So altogether, this is entirely what the Snyk platform is, providing all this insight into all the layers of your application where the vulnerabilities are coming in, but always thinking about how the developer can make a change, an update, or a change to the way they're doing things in order to make that more secure. Let's just look, for instance, at a developer's workflow here, as we've got stylized on this screen. So a developer comes into work and they have their legacy code or existing code stored on an SCM tool. Their Snyk can scan the code, the open source, the containers, and the infrastructure as code. They then check that out to their local machine. In their IDE, they're creating a new feature, fixing a bug, preventing or doing some site reliability changes. And in that IDE, again, we can scan all 4 of those layers. Once that work is complete, a developer then creates a pull request, pushes that back into the SCM tool. And again, Snyk can check and fail pull requests if we find vulnerabilities have been found as well. What usually happens after that pull request is an automated CI or CD build gets kicked off as a result of that merge. And again, Snyk can integrate there. Even when you then store these resulting artifacts in a registry, Snyk can scan there. But we're always thinking, going back to what should the developer do in order to fix this? The reason I told you about all the integration points that Snyk works at is not because you need to integrate with them all. It means we can understand how our customers want to work and choose from this list of integration points where would be best to make them more secure while not while still keeping high developer velocity as well. So I just wanted to take you a little bit through the platform, not too deeply, but let's have a look at the platform from a kind of high level to give you an idea of what that actually looks like. So as I log in, you can see I'm in my Paul group. That could be your company name. And underneath that, an organization could be a group of projects, a business unit. However logically you separate your work or applications, that can be set up with inside Snyk. And you'll see here I've got a number of projects, each of which have been scanned with the number of vulnerabilities to the right. If I then go and open up one of those, you'll see the individual layers of that application that are being scanned. So I've done a scan of the Docker file. I've looked at the package.json for the open source. I've analyzed the code for the developer written code, and I've got the deployment.yaml, but that could be Terraform, CloudFormation, as I mentioned before. So as I go in and start to address some of these vulnerabilities, you'll see something that's a theme throughout all of Snyk's reports around these. And that is, it's about prioritization, It's about remediation and then education. So here we've got a prioritized list of vulnerabilities. This one happens to be NoSQL injection, and it's at the top because it's found in multiple sources. It's found in a pile appearing in multiple code flows. So this code gets used a lot, and it has fixed examples. So immediately now I know this and the one below it are the most important things to fix. I can then use the taint flow analysis or the data flow to actually step through that vulnerability, understand how it's manifest in my code. If any of you are coders, I'm hoping that you can easily get this vulnerability, in fact. But essentially what we're doing here is we're taking input from a request that's coming from the front end. And before we actually, it's actually being used in a user find before we actually sanitize any of that information. Essentially, we're expecting a string, but if we're past an object, we'll still use that in the find. And this is basically what the fix analysis tells us here, along with showing how other people have fixed this problem as well. Just a simple toString on that inbound request will fix this one in this case. There are better ways to fix it, however. So essentially we're seeing here, now we can go and fix this one. But if we're not too sure of actually what we've been shown there, as a developer, I can go in and take a lesson about NoSQL injection in the language of my choice to understand what it actually is. I can then do a practical lesson where I can learn to actually hack a website with NoSQL injection. And then I can look under the hood to find out what's actually happening and then learn how to mitigate that from a base principles type. So we provide these contextual lessons whenever developers come across certain types of vulnerabilities. And here you can see, if I go back to the next part of the project, you'll see a similar thing in the open source as well. Here I've got my open source report. Again, prioritization, remediation, and then education. These are my top issues, and we can see organized by the type as well. If I go into this one, for instance, I can see the problem here. I can partially fix this vulnerability because in this case, I can upgrade one of the packages, but the other has no package remediation path. That means the top level package, EJS locals, has not actually fixed that problem, but at least we can fix the one in this particular package here. And I could go and create a pull request to fix that vulnerable path. And then perhaps what I do with that other vulnerable path is do something like create a JIRA issue, open an issue perhaps in Slack, or do some other task that would mean we need a war room or discussion about how to solve that problem. And then again, Snyk is showing you that remote code execution. If I really want to understand what that is, I can go down and start looking at the problem. I can have a play myself in the terminal that we provide. And as you see, we go down and we understand more deeply what that problem is and why it's important to fix. So that's that second layer, that open source. And then just quickly, we've also got things like the Docker file. The Docker file is important because often developers just get given Docker containers or Docker files, and they're told to use them. We call them golden images. But often it's very easy if a developer has a tool to think about upgrading these things when they are vulnerable. If, for instance, I was given this image, which uses Node 1410, hopefully I wouldn't anyway, because that's quite old now. I can very easily see I could do a minor upgrade to reduce nearly by half the number of vulnerabilities, a major upgrade to reduce by an order of magnitude-ish the vulnerabilities, or even alternative images to reduce them even further. Again, just open this pull request and we fix the container. Downstream, we've got a lot less vulnerabilities on our live environment. So the last thing here, which is more related to the things we're doing with HashiCorp, is around the infrastructure as code. This particular example is just a deployment.yaml, but it's the same if we look. I can show you the rules shortly. Essentially, we have a policy. That policy looks at the types of files that you're creating, which result in the types of resources on the cloud. When your files, your configuration IAC files do not meet this policy, we will let you know. The container doesn't drop all default capabilities in this case, The issue is all default capabilities are not dropped. The impacted containers are running with potentially unnecessary privileges. And here we can see the resolution. Add security context, capabilities, drop list to your file. And again, if I don't really understand why that's important, I can go and take that lesson again and start having a practical example. Out of interest, any lessons that you do take are marked against you as a user in the platform, and your manager or your team leader can have a look about how many of these lessons you're taking. We even provide things like learning paths for OWASP Top 10 and the Snyk Top 10 vulnerabilities. So all in all, we're helping you within that whole kind of developer workflow to find and fix these vulnerabilities that you have within your platform. Now, I showed you everything today in the Snyk UI, but all of these capabilities are available in the IDE. We also didn't show you things like the SCM tool, but what I did just want you to show is this new feature that we're launching. It's called Snyk Insights. It's where we're now not just giving you the number of vulnerabilities, but we're trying to answer that real question. What is actually vulnerable in my environment? So in the past, where we would have just said to you, we have 4,855 vulnerabilities. Now we're tracking that application across the DevOps pipeline. Its containers, where are they deployed? In which pod is it deployed as well? So we can start to say, of those 4,855, we can only see 2,745 actually on a container operating system. Now, of those container images, which ones are deployed on a live environment? And here we can see there's 2,245. Added to that, we can then say which ones are actually found on a public facing pod. That's 1,395. And then in this particular case, we can also add this loaded package. And what that is, that's an integration with some of our observability tool partners, things like Dynatrace, things like Sentinel-1. Now, I've not properly set up actually that integration yet. That's why you're getting the 0 on that one. Once we've got the loaded package set up, we will have more information. But at the moment, we know there are 1,395 vulnerabilities on a live public-facing pod that we should be addressing. And here is the list of all these issues. I can then go into that project and understand, great, now that I've removed all the ones on public facing, let's go back and remove the ones that are just deployed, and we can work our way back, ensuring that the developers are actually thinking about risk rather than just vulnerabilities and removing those vulnerabilities as we go forward as well. Okay, I've pretty much finished my demonstration there. If there's any questions, if not, I will hand over to Andre.
Paul, there's actually a question in the little window here. It says, can Snyk help us understand the actual risk from the vulnerabilities rather than just the number of vulnerabilities?
Ah, yes, that's what I was just addressing in that. Let me please just go back to this again. So the real reason we're kind of doing this is because that we've identified that some customers with large legacy estates don't really understand, or they have too many vulnerabilities to address. And we're addressing this in a number of ways. First thing, okay, let's think about your inventory. So we'll come in and help you understand actually how many repos do I have? Throughout history, I may have had a lot of SCM tools, some deleted, some deprecated. So let's just first do an inventory. What is there? Once we've got that full inventory of all your vulnerabilities, we can then say which controls are actually around those vulnerabilities. So which ones are being scanned by Snyk code, open source, external tools as well that we can integrate with, which ones have lapsed. Perhaps we've scanned them in the past, but we're keeping that scan up to date. And in some cases, you'll see that some things are not scanned at all. So that's the first stage, inventory. Then what we want to do is actually start looking at the policies. And Snyk can now create policies around your assets to say things like, if I have a class 1 asset, I want to make sure it's scanned every day. I want to make sure the code and the open source is scanned every day. And we can build rules that look like this coverage policy here. So if there's an asset type A, and it's filter live, then set the coverage control. And we can see if I go into these, what's actually happening here. A repository, that's one of these languages. Make sure that Snyk open source is scanned every day, and make sure that Snyk code is scanned every week. So once we've got that inventory, we then create policy around it. So we know now what's actually risky, what's important. The last stage is what I just showed you before, that insights. Once we know what everything is, what class everything is, what environment it is, we can start to track through all the developers' work and then start to understand which of these vulnerabilities are actually risky because they're live, because they're facing the public, they're open, because they're part of our payment gateway, for instance, or they're controlling customer information. And once we understand our whole estate and we've done a full inventory and created policy, then the developers can be put to work fixing things that actually provide risk to the environment as well. Hopefully that answered the question. Okay, I think it's over to you then, Andre, unless there's any more.
All right, excellent. Thank you, Paul. And I was actually going to recommend to folks, or remind folks rather, that we do have that Q&A panel open, but you already beat me to it. So I will start sharing my screen.
Excellent.
So thank you for that handoff. So again, everyone, my name is Andre. If you haven't heard about me before, or about us before rather, Gremlin is an enterprise reliability platform. We want to help teams just like yours find and fix your reliability risks before they become incidents and outages. And we focus mainly on 3 key areas. First is reliability risk monitoring, resilience testing, and chaos engineering experimentation. We also help enforce resilience standards and helping teams meet governance and compliance requirements. Then we also help automate reliability best practices throughout your software development lifecycle. So we really help complement that security process that Paul and John both introduced earlier. And we're used by a lot of the world's largest organizations with really high costs of downtime. Banks, fintech companies, retailers, a lot of household names too. Companies for who reliability and security are kind of the name of the game and really critical to their success. So we've talked a lot about security, and before we get too deep into things, I wanted to talk a bit about why reliability is important and how it kind of goes hand in hand. First, security and reliability are both organization-wide practices. They both use tooling, of course, but they also require engineers and operation teams to understand why it's important and, of course, how to prioritize it when you're busy doing other things like development and new feature releases. Both also use a combination of both passive scanning and proactive testing. By this, I mean you can use tools like HCP Vault Radar and Snyk to, of course, poke and prod at your systems and figure out where security vulnerabilities lie, and also do continual scanning, of course. And reliability testing is very much the same. You run tests to see how your systems respond under certain conditions, but Gremlin also scans your services in the background for those reliability risks that it can detect automatically. Both, of course, use reporting, which is really important for determining the state of your systems, what vulnerabilities exist where, and where you should put where you should prioritize your work. They also often list recent incidents so teams can learn and improve. Essentially, just like you manage a security posture, you can also manage your reliability posture. The main difference is that security problems are often actively exploited by bad actors, while reliability problems can crop up anytime. But really, one of the most important things is that, you need to be able to actively look out for both things. Security and reliability are both proactive problems. So having a way to actively look for those and address those is super important. So like I mentioned earlier, we work with a lot of household names, a lot of really big names, and working with these companies means we're in a really good place to get insight into their reliability posture. And some of the things we found during this research is that every single organization had one or more critical reliability risks in their production environments. What does that mean? By reliability risk, I'm talking about any potential point of failure in your system where an outage can occur. Left alone, these risks have potential to take services offline for hours or even days. We've all heard about major outages across a bunch of different industries that affect thousands or even millions of people. These are the types of high severity issues that we want to help prevent. So, your bank, your airline, your favorite online games, whatever it might be, these are the teams that we're working with. Now, these companies are doing a ton of great work. They're making a lot of significant investments into improving reliability. This is nothing against their processes or their people. the point is that even their systems aren't foolproof. And a lot of these risks are just really kind of simple, common misconfigurations that are hard to know about when you're doing a migration, or that just gradually creep into applications over time. The problem, of course, is that even simple, small misconfigurations can cascade into much bigger problems. And when things start to go wrong, like let's say you have more demand for a resource than you expected, or your cloud provider has a zone failure, these simple, small misconfigurations can really balloon into cascading failures and cause more harm than you'd anticipate. So what do some of these risks look like? A lot of our customers work with Kubernetes, so we have a ton of Kubernetes data points, but you can imagine similar risks on different platforms. So one example, 80% of the deployments that we see lack 3 or more availability zone replicas or redundancies that AWS recommends in their well-architected framework. This means that if you're deployed in AWS and you only have 2 availability zones and both of those fail, or even if one of those fails, it's going to be really hard to recover. And even if some of those deployments have zone redundancy, 1 in 4, about 26%, don't even have that. So if one AZ goes down, then that's it, they're offline. Another 25% lack memory limits. So this is the maximum amount of memory that a pod can use to avoid draining resources. Not having this means you're susceptible to things like memory leaks or memory, a pod using more memory than you'd expect, which can have rippling impacts on other deployments there. And 1/5, or about 20% of objects, are bare pods, meaning that they're not being monitored by Kubernetes. You're not able to easily change how many replicas there are to be able to scale them, and it's really hard to implement redundancy. So they're just kind of floating there unmanaged. Now, the good news is that most of these are really easy to remediate. The hard thing is knowing where to look. But because systems are changing so rapidly, we're migrating to the cloud, we're building bigger and bigger deployments, we're scaling up faster than ever before, that looking process is actually a lot harder than it seems, and we're here to help out with that. So here's what it looks like in practice. Teams that start out with Gremlin usually start by recreating past incidents and outages. Right, the only way to really understand the resiliency of your systems, just like their security, is to test them. So we give you a suite of different reliability tests and chaos engineering experiments that you can choose from and customize to recreate basically any kind of outage you could think of. But we also include those pre-built reliability tests to give you a bit more guidance in case you're not sure where to start or want to know what other what industry best practices are out there. Once you've done that, you can use your findings to highlight your biggest reliability risks. So for example, let's say you have a critical service that's a core part of your application that's failing one test or multiple tests, then this is just a ticking time bomb waiting to disrupt your users' lives. So what we do is we help build reliability scores for each service based on those different test results, so you can better prioritize those risks and communicate them across your organization. And then, of course, you can automate these tests and repeat them to get an always up-to-date view of your reliability posture. And you can click into those risks, understand where they are, and be able to actually drive a path to action to resolving them. Then finally, as we run tests repeatedly and are able to fix specific risks, we build confidence in our systems over time. And this is the most important thing. This is what reliability is all about, is feeling confident that our systems will keep up and running regardless of what production throws at them. So that's why we incorporate things like those reliability scores and dashboards so that you can continuously monitor, measure, and improve your reliability no matter what level it's at. It could be the service level, infrastructure level, and of course that overall organization level. So to give you an idea of what that path looks like, when folks first start with Gremlin, they usually know us at this chaos engineering company. They ask us questions about what chaos engineering is, what it's like to inject fault into systems, but what exactly does that mean? So chaos engineering is simply a way of injecting fault into a system to see how it responds. And we call this controlled failure specifically controlled for a very important reason. Like, technically, you can just walk up to a server in a data center and pull a plug, and that's creating failure. But that's chaotic, and that's really hard to recover from. So controlled is something that we emphasize because that means that the faults you inject using Gremlin can be stopped and reverted at any time. They also don't have any direct impact outside of the systems that you specifically target, and they don't make permanent modifications to the systems you're testing. So instead of going up and pulling the plug on a server and getting yelled at, we could do something like issue a restart command, or better yet, use something that we call a black hole experiment, which drops network traffic to the server, making it seem as if it was offline. And with that black hole experiment, if we need to stop it, we can just click a halt button in Gremlin. You can actually see it in the top right corner of that screenshot. And that experiment will immediately end, and those network rules will go right back to normal as if nothing happened. We can also run more basic experiments like increasing CPU to 80% to see if our cluster scales or our app remains responsive under load. Again, it depends on how your systems are designed and what pain points you're trying to solve for. Now, the security equivalent of something like this would be something like penetration testing, right? You're basically prodding your systems for vulnerabilities. In this case, we're just looking for reliability gaps, not security gaps. But like with pen testing, we can take our learnings back to our desk, work on patching those vulnerabilities, deploy fixes, and then repeat those tests to make sure that they're no longer present. And the next step in this process is automation. And the way we tackle this, and rather the first step towards tackling this, is what we call detected risks. And detected risks are simply reliability vulnerabilities that exist in your systems that Gremlin detected before you have to run any sort of chaos engineering experiments or inject any faults or run any reliability tests. So an example of that, let's say that you're running on the cloud and we notice that you only have one availability zone tag that's common across all of your systems. We'll flag that as an AZ redundancy risk and encourage you to deploy across multiple AZs in order to fix that by adding that redundancy. So to help you with that, we give in-product explanations of what the risk means, why it's a risk, which of your services are impacted about it, and of course, how you can go and fix it. So before you even do anything in the app, as long as you install their agent, you've already got a scorecard of things that you're doing correctly and things you should check up on. And of course, you can also take your chaos engineering experiments that you've created and automate them so that you're constantly up to date on whether your systems are vulnerable to specific reliability risks or not. The goal here is to be able to stay ahead of any like configuration drift issues or regressions so that you can fix them before worst comes to worst and your customers find them. And lastly, all of this bubbles up to our reports. So just like you want a security scorecard showing your security posture, Gremlin gives you a reliability scorecard showing your reliability posture. The one I pictured here is our team risk report, which shows you those detected risks I mentioned earlier and how they've changed over the past 90 days. For detected risk, we use a simple pass-fail system. Either you're vulnerable to it or not. Chaos engineering tests are a little more complicated. We use pass-fail and expired. The reason we haven't expired is because your systems change over time. Like I mentioned, you can deploy new fixes, you deploy new releases, your infrastructure changes. A chaos engineering test that might have passed a week ago or a month ago might not pass today. So you want to be able to periodically run those tests so that you're constantly up to date and that you can feel confident that your systems aren't vulnerable to those old risks that you might have passed earlier. And we also flag those old outdated tests so you know what you need to do to catch up. So I talked a lot about tests and testing. What exactly do some of these tests look like? So here are a few examples that we've seen by our customers. I won't go over all of these, but they just give you a good idea of some of the tests that you can run in practice. Most importantly, each test starts with a question about our systems. Let's say we have a Kubernetes cluster with pod autoscaling configured. Our question might be, when our cluster reaches a point where the autoscaler should get triggered, does it actually get triggered and does it scale successfully? So to test this, we can actually use Gremlin to run a test where we consume CPU in the deployment where the autoscaler is configured. We can configure the test with different parameters like how much CPU to use, how many cores to use. So that way we can actually accurately trigger the scaling threshold without going over and without impacting too many systems. Then, of course, we observe the autoscaler to see how it responds. If it triggers the way we expect it to, then great, we've passed the test. We can mark it as a success. But if it doesn't trigger, then we have to mark it as a failure, go back, maybe review our autoscaling rules and our HPA rules, and then we go back to the beginning and repeat the test. And we repeat this process until the autoscaler consistently works the way we expect it to. And that's basically how the structure of a test works. You start with a question, challenging the built-in behavior of your systems. You run a test to test that question. You get the result back, whether your systems responded the way you expected them to or not. And then if they didn't, you take action to fix the issue and then confirm that your fixes work in practice. And so all this rolls up into what we call the Gremlin platform. Starts with, of course, helping you find those reliability risks in a safe and secure way by helping you recreate past incidents and those specific failure modes. We help you standardize reliability testing through what we call test suites, which are those collections of tests that you can assign to every service in your team or in your engineering department, or however you might have it structured. Again, we offer pre-built tests based off of industry standard reliability best practices, but you can also bring your own. If you have your own standards or your own controls that you want to test your teams against, you come in, build your own test suite, and we automatically assign that to all the services within your organization or your team. We also support large-scale testing. Many of our biggest customers, rather, will run tests where they fail over an entire availability zone or an entire region, which, as you might imagine, for a financial institution, takes a ton of coordination and process management. So we built that into our product. We have a feature called the Game Day Manager, which helps you manage this by coordinating the folks in your team, the tests that you're going to run, and which time you're going to run them. All this gets funneled up into our report, so you can see exactly where your reliability posture lies for individual systems, services, teams, or the organization. And as I mentioned earlier, we work with some of the biggest companies in the world. A lot of these companies are very concerned about running these kind of testing on their systems. So we built for them first and foremost, right? We've built for enterprises. We really are strict about how safety and control are integrated into our Gremlin agent and our Gremlin backend. They're some of our top priorities. And so we work directly with security teams in these companies to make sure that you can get the most value without putting your systems at risk. And I just want to end with some additional resources if you'd like to learn more. We have a full guide to chaos engineering on our website. This will tell you way more than I can at this time about what chaos engineering is and how it works in practice. I also wanted to link to our security practices. Even though our product isn't directly related to security, we still treat it very seriously. Again, a lot of our customers are financial institutions with very strict security processes. So we put everything out there. Also want to link you to a blog that my colleague wrote about how you can treat reliability risks like security vulnerabilities. So you can sort of get that link and that connection about how they're related. And then, of course, if you ever want to get in touch with us and to see how Gremlin works in practice, you can do so after the webinar by going to gremlin.com/demo and get in touch with our team. So now I'll hand it back to John to wrap us up.
Yeah, actually, Andre, we have a question in here.
Sure.
And I think, I don't know, you kind of discussed it, but how do you prioritize reliability testing when you're already focused on other things like security, product development, et cetera, et cetera? Sorry, go ahead if you're going to answer that. Yeah.
All good. Yeah, so it's a really good question, and it's one that we hear a lot. Is you're working on a bunch of other things, you're focused on a sprint or whatever it might be, and you're not sure how you're going to be able to cram reliability in there. And really the thing is that reliability work is one of those things that you do upfront to help give you more time in the future, right? So the big risk with not doing reliability testing is that, let's say you're working on a new feature and you deploy it, and a month, 2 months down the road, something happens where that feature causes an incident or an outage. So now you have to jump up and respond. You know, you have your folks on call, jumping onto it. You're spending a bunch of time trying to troubleshoot and fix the issue. This isn't saying or implying that, you know, something that you work on is going to fail into the future, but it's something that we see time and time again. So reliability work is taking time in the present to actively work towards preventing that and making your services as resilient as possible so you don't have to worry about responding to them in the future. This also has knock-on effects for things like performance and, again, security. When you do more proactive testing, you're able to catch bugs sooner and just, you know, make the work you're doing that much more effective and that much more resilient. Oh, and to second part of your question, how often should a company be testing in prod? That depends on your maturity level. We recommend that folks start with testing in pre-production just to get a feel for chaos engineering and for reliability testing. And also just to understand how your systems work. And when you move into production is when you're ready to automate that process. So when you're ready to check your systems against regressions, that's when you move into prod. And also, that's why we offer so many tools for safety and recoverability, not just that big red halt button that brings your systems back to normal, but also things like health checks, which integrate with your observability tools. So between those, you can run tests in production once a week, once every, or a couple times every week, or maybe you have a big block scheduled every month where you just run through all of your tests. It really depends on how mature you are within your reliability journey and how critical these services are to you.
Excellent. Thank you, Andre. And regrettably, it won't let me re-enable my video now because I turned my video off. I can't re-enable it. So we'll just sign off here. But thank you, everyone. The recording will be available. Hopefully that will be useful for people who couldn't make it. And thank you for joining, and thank you for if you're watching this far to watch through to the end. Any of these questions, any of the solutions you liked or you have questions about, feel free to reach out to either TerraSky directly or again NewAware, which is the distribution partner for all of us. Right? Thank you very much. Paul, anything else? You okay?
Yep, all good on my side. Thanks very much for the invite and allowing us to showcase Snyk. Thank you.
I appreciate it. Yeah, thank you very much. All right, well, take care, everyone. We'll see you later.
Cheers. Bye-bye now.
Thanks all.